Woo!
You're alive.
All right.
We did
Fraser, how's living up there? You still in the trailer? And
it. Yeah.
oh my goodness.
I know it looks like I'm out in deep space, but I'm I'm still in the trailer.
Same thing, right? No.
Yeah. But the update, we just poured the pad for our pump house today.
Okay.
So, and we've got the system installed. So now we will have water, potable water soon. I would say we're probably about 3 weeks away from potable water.
Nice. Are you doing? Are you like buying big bottles of water, big jugs at this point?
No, I have 4 canteens that I take into town every week and go to an old neighbor's house and fill them up and then dump them into the trailer. And so we go through about 100 liters of water. No, it's about 150. About 150 liters of water a week, and that includes showers for Carla, washing the dishes, all our drinking water, dog, etc. Yeah.
I thought you were much closer to being in your place than that.
No, well, we are. I mean, we're getting cabinetry done. We're going to be pouring the outside pad for the concrete for the driveway and the deck. Painting this to probably start painting tomorrow.
Oh my goodness.
So,
okay.
Yeah, so the actual place, things are coming together, but still I have to go and pick up propane every week, and yeah, it's it's still a very
little rustic but civilized.
Not at all civilized, all rustic. Yeah,
all no rustic.
Yeah.
Well, you're not in a lean-to under a tree. That's
no, for sure. We're in a trailer. But again, it's kind of like, I think, I've mentioned this often that, people have romantical notions about what it's like to live in a trailer. Man, it sucks. It just sucks. Every part of it is the worst.
Yep.
Yeah.
Can imagine.
Don't do it. Don't do it. If you think, oh, I want to live trailer life, I want to just like drive, just live in a van, be cool, man. Like, okay, that's what you say. I don't believe you.
It's like a lot of things.
Maybe if it's just you don't have responsibilities or a show that you put on or any of those things.
Yeah, I guess that's the key, right? Is that if you're going to live the trailer life, you also ditch all of those. The whole point is that you can then live footloose and fancy free as you roam the landscape of taking in your nation's parks, as opposed to attempting to continue running a business and live stream from the back of the trailer with your Starlink. Yeah, but yeah. So there we are. No van life vlog. No van life vlog from me. But man, the new studio is gonna be so good. I've got so many plugs. Got just like, when I sit down, I've got probably 12 plugs in front of me, like electrical outlets.
You think that's enough?
I'm worried that it's not. Yeah.
Okay.
Have you not just like tried to set up computers and all their assorted shenanigans? No, you need a lot of plugs. Yeah. So, but it's going to be fun. It's going to be fun. And you know what? And I talk about this, like, when you get something, when you change your lifestyle, you have this hedonistic adaptation and you're like, oh, you're so excited. And then you're used to it. And so now by suffering, we will just hug the dishwasher every day. Thank you, dishwasher. Thank you.
Projected move-in date?
Probably about a month. I think we're about a month away.
Month? Ooh.
Yeah.
That's good.
Yeah. So it's not going to be not that long. And then I'm going to build a little observatory.
Yay.
And by observatory, I mean box that I can open up with a telescope.
Roll off.
Yeah. I think my plan, roll off, or just like my plan is like a box that has a hinge on the back. And then I'll be able to open up the hinge, and then the box will just kind of flap open. So now it's just lying on the ground, and then the telescope will be revealed. And then
just for the scope itself.
Yeah. And then I'll just control the scope remotely from inside.
Oh.
Yeah.
Okay.
Yeah, that's the plan.
All right.
That sounds nice.
Yeah, I think that'll work. And because it's like, once you get it on a pier, and then you polar align it that one time on a pier, and if you've got a nice mount, then you're kind of set. And so it's definitely it's just going to be a pier mount, telescope sitting on top, align it all once, and then call it a day. And then hopefully then I can, take pictures because the sky is beautiful. The nights are really dark when it's not raining, which is rarely. But anyway, we should get started. But just to warn everybody, we're definitely shorthanded this week. So we might just babble. I might throw a bunch of additional news items in that we're just going to talk about for no reason.
Cool.
I might end the show early. You may have a ton of questions, and I'm going to have lots of time to answer your questions and also get Moy and Pam to answer all your questions as well. So
I love it.
Yeah.
Or at least try to.
At least, yeah, exactly. No, you will. I have faith. You're at least questions that are, in your wheelhouse anyway. All right.
We'll just make up.
Yeah, fine. Make up answers. That'd be fun too. Okay. So hello and welcome to the Weekly Space Hangout for Wednesday, March 23rd, 2022. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about just lots of news stories. We're going to be talking about 5,000 exoplanets, flyby of Ganymede, spring, what to see in the sky, SLS, James Webb, Starship, and more, maybe? All right. Joining me this week, we've got Moya McTeer. Hey, Moya.
Hey, Fraser.
Doctor.
Doctor.
Captain.
Yes,
Professor. Dr. Moya McTeer.
Yes, because I went through the Weekly Space Hangout boot camp that guarantees you become a doctor at the end of it.
And the very least that we can do is then, refer to you by the doctorate that we custom got for you. Yeah, absolutely.
Yeah, it's a great service that you do.
It really is. It's the least I do for you. All right. We've also got Pam Hoffman. Hey, Pam.
Hello.
And are you working on your doctorate? No?
I would like to eventually. So I will stick around until I'm ready.
That's how it works.
That's how it works.
Yeah.
I love it.
It's a lottery, I think. It happens
Okay.
randomly. Yeah.
I didn't think so, but okay.
Yeah. So Moya, your internet sucks.
It does, but I will do my best.
Yeah, exactly. Like, just focus. Actually, the answer is don't move. Just.
Oh, okay.
Yeah, because the more you move, the more you are sending bits back and forth because it can't compress as easily. And so if you just don't move, then you're sending a very high compression data stream, and you're not going to handle it. All right.
Cool.
Before we get into this week's news, I want to give a huge thank you and a shout out to our good friends at the Weekly Space Hangout crew. They're our executive producers. They call the shots. We do what they say. Special thanks, of course, to Nancy Graziano for really helping keep everything really organized. If you want to be a part of this amazing community, go to wshcrew.space. They will hook you up. All right. Let's get on to this week's news. Moya, 5,000 exoplanets.
5,000. We reached 5,000 this week. It was announced on Monday, I think, from JPL that the 5,000th confirmed exoplanet was discovered. This is not only the 5,000th exoplanet that we know of. This is just confirmed. There's a special process that you have to go through to become a confirmed planet. You have to be confirmed and detected with at least 2 independent methods of finding exoplanets. There are a bunch of different ways that we can find exoplanets. You can look at pulsar timing, seeing the difference in the amount of time it takes light from a pulsar to get to you if there's a planet around it. You can look at radial velocity, which is seeing how the gravity, how the mass of a planet tugs on a star and makes it wobble a little bit. You can also do transit photometry, which is my personal favorite, looking at the shadows cast by these planets, or direct imaging, where you actually just take a picture of it, or micro lensing, where you wait for the gravity of this planet to bend light from around it, or astrometry, which I think has only found 1 planet to date. It's kind of like radial velocity, but instead of the star moving towards and away from you, it's moving like up, down, or side to side. I would love it if we found more astrometry planets.
Yeah, that next release from Gaia is going to be a boatload
I'm just going to keep going, assuming you can still hear me.
We can hear you.
If not, please put something in the chat.
You sound great. It's the visual that glitches a little bit.
Keep going. Keep going.
Okay, great. Awesome. So the first exoplanet was found in 1992, which is actually before I was born. It was orbiting a pulsar found using that pulsar timing method. The second planet, the next planets, were found in 1995. Those were the first planets around a sun-like star, but it was not an Earth-like planet. Instead, it was a hot Jupiter with an orbit of about 4 days. So it goes around its star every 4 days. And now it's 30 years later, and we've crossed the 5,000 threshold, and that has covered all types of planets. One of the images that I put in the slideshow is the Kepler orrery, or one of the Kepler orreries. And I highly recommend you look up these videos because you can see all of the different systems that we found and their relative sizes and how many planets each of them have. So that's a great way to spend a few hours on YouTube. But just some stats about these planets that we've found. About 30% of them, a third, have been gas giants, and some of those have been hot Jupiters, which has opened this question in exoplanet science of how do hot Jupiters form? Do they form really close to the star, or do they form farther away and then migrate in? Exoplanets in general have really expanded the amount of research questions that astronomers ask, which I really love. Most of the planets we've found fall between the sizes of Earth and Neptune. They're either super Earths or mini Neptunes. And less than 5% of the planets that we've found are rocky terrestrial planets. But it's still important to know they're there and that Earth-like planets, I'm using air quotes, that they aren't super rare. Most of these planets are relatively close. They're with 4,900, so all but 100 of them are within just 1 kiloparsec, or a few thousand light years. And it's important to remember here that there is a big observational bias. Each of the detection methods that I talked about before, they have their own strengths and weaknesses, but generally speaking, it's easier to see big, massive planets and planets that are closer to their stars. So I'm really excited to see the number of planets grow even more beyond 5,000 with missions like TESS and Cheops coming out of the European Space Agency, and of course JWST, which I think we'll talk about later.
Mm-hmm.
Cool.
So what would you say are like the big takeaways now that we know 5,000 exoplanets? What are like the big takeaways that we're starting to learn about exoplanets? She can't hear me, can she?
It doesn't sound like it. Can you?
Moya, did you get my question?
I think I heard a question there.
Yeah. What do we know about planets?
I heard what's the big takeaway?
Yeah. Yes.
Well, we know that Earth-like planets aren't rare. That was a big thing that we were interested in finding, especially when we launched Kepler in 2009. And it then found a lot of these rocky terrestrial planets close into their stars. I think another thing we now understand is the distribution of planets' multiplicity, like how many planets can we expect to be around different types of stars. Before, that number wasn't really constrained, but now we understand that there are probably a couple planets for every main sequence star, and that's a big deal.
Yeah. Wow.
And what do you think the future holds? I mean, 5,000 today, how many are in, like, are candidates, and like, how do you see those numbers rising?
Yeah, I think there's probably on the order of 1,000 candidates. There are things being pushed through the pipeline all the time. I know that there are probably plenty of grad students and little undergrads who are actively working on exoplanet characterization papers. I know because I was once one of those undergrads. But going forward, I expect that we're going to find a lot more exoplanets, and that we're going to move even more into what I call the era of exoplanet statistics. It's no longer interesting really to find a single exoplanet. I mean, it always is, but now we can start to understand these systems on as an ensemble, on a population level, to really understand more about how stars and planets and the systems that encompass them form. So I think that we're going to find more exoplanets. We're going to learn more about the statistics, and probably not in my lifetime, but one day, I really want to say we're going to find life.
Yeah. And what about the techniques? Because in the past, the techniques were mainly the radial velocity method and the transit method. Now we're seeing a little bit of astrometry. Direct imaging is planned now with some instruments. What do you think the future holds for technique for finding planets?
Mm-hmm.
There must be a lag.
I think that we'll probably still continue to find planets using the transit and RV methods. But I think that we'll move further into studying the atmospheres and surfaces of these planets. That's what I'm most excited about with James Webb, for example, which goes more into characterizing them and understanding them on population levels.
Right. So I can kind of imagine we'll get to a point where we know we have characterized the atmospheres of 5,000 exoplanets, as opposed to just knowing of their existence, which will be quite exciting.
Exactly.
Or we'll know of 5,000 atmospheres that contain water, or 5,000 atmospheres that have ozone. there was a paper that I read,
or 5,000 with a bunch of biosignatures.
yeah, oh, that would be great. I read a paper a couple of years ago. They were predicting 50 million planets by 2050.
Wow.
So
Ooh,
yeah, so that there
that's
are
a big jump.
It is, but if it's just if you look at sort of just the traditional rise and speed and the quantity of planets that have been discovered, and then you just chart that exponential growth curve into the
Mm.
future, you end up with like 50 million or 10. Yeah, it was 50 million, I think. Maybe it was 10 million. But anyway, it's in the tens of millions of planets identified, just because we will have bigger, more powerful telescopes doing all sky surveys, and new
Mm-hmm.
techniques will be developed that we don't know what they're going to be. Astrometry alone might be the one, a super Gaia might be the machine
Right.
that does it, because it can see planets that aren't directly edge on. It can see them at many different angles.
Yeah, I think that's not unreasonable, because we're going to have bigger and better telescopes. We'll have bigger and better computer programs that can use maybe machine learning to go through and find planets that humans wouldn't necessarily say when they're looking at the data, oh, that's a planet. And yeah, the all sky survey thing is going to be really valuable too, because up until now, the most successful exoplanet finding mission was Kepler, which just looked at one patch of sky for 4 years and then moved around the ecliptic. But we really haven't explored the whole sky and taken advantage of that yet.
Yeah, and like Nancy Grace Roman through the transit system is going to find probably 100,000. I think is the plan.
Amazing!
Wow.
I love that.
Yeah, it's just going to be incredible. So, so I guess stay tuned.
So
All right.
was one of those the kind of thing that people can contribute to and help with? Is that what I heard? That there is a method that people can look for, like we're seeing comments with Soho.
You can confirm them. So
confirm them. Okay.
Yeah. So there are citizen science projects that you can get involved in, where you can do follow-up observations on planets that have been discovered by Kepler and TESS, and then you can do follow-up observations on those stars. I mean, theoretically, you could find them if you knew if you knew exactly which star to look at, and you got your timing right, and you stared at it night after night after night for a couple of years. You could probably detect exoplanets all on your own. But the whole point is that that a typical backyard telescope is powerful enough to confirm an exoplanet with the transit method if you've got you need to have the right camera set up. And then the other thing that you can get involved in is transiting planets. So after a new transit has been discovered, they'll often want other observers to observe that transit just right afterwards, and see if you can see you hand in your signal and everybody puts it in together, and they crunch the data, and sometimes planets come out of these transits. So there are a lot of ways. And even if you have a backyard telescope, we've covered some stories in the last couple of years about groups of citizen scientists confirming a bunch of the planets that are in the Kepler data, TESS data. So I think we're going to see even more reliance on this into the future. I know some of the new automated telescopes, like the Stellina and the other one, I forget what it's called.
Is Chandler? Do they have a set?
It's the ones that you just set them up, and they just find their spot in the sky and start taking pictures and stuff.
Yeah, we did a show about a set of those.
Yeah. And so those, you can sort of sign on to the network and be part of the system. So it's pretty cool.
Yeah, even sifting data, I think, is really good for people, because the computers don't always figure out certain things.
Yeah, and what the computers will flag as a potential planet is based on patterns that we have coded in those computers. So if there's ever a weird system that doesn't match that typical pattern, it wouldn't get flagged. So it's really important to have human eyes going through and looking at that.
That's cool. I didn't realize there were so many different methods now. That's great. Thank you for that.
Yeah, it's cool.
Yeah.
All right, Pam, speaking of things you can see in the sky, what can you see in the sky?
Yeah, well, and I like to talk about things you can do too. So I have things you can see in the sky, and I have some little projecty things. But the planetary action has remained in the mornings. Venus is high and bright, and it just passed greatest western elongation. That was March the 20th. But some other highlights include, of course, our shows. You've got this one on Wednesday. We've got one on Friday. There's a meteor shower coming up in the next month. There are some, like I said, some cool activities. There are 2 Globe at Night projects between now and the next time I'm probably going to be on the show. And while there are 12 conjunctions in the next month or so, most are at the end of April, and only like 3 are worth mentioning. So I want to talk about this, European Space Agency's Build Your Web Challenge. I've mentioned this before, but it's still going as far as I can tell, and for anybody in the whole world. I do have a slide about that, Pamela, if you don't mind showing it. Yep, there it is. And you can actually basically just submit your offering, and they will put it in their gallery. This is for anyone in the world, apparently, and they're asking for youth who are 6 through 19, homeschooled, regular school, anywhere in the world. A new one is you can fly your name on the Artemis 1 test flight.
Yeah. Already done.
Very cool. Did you do that, Moya?
No, I'll do it after this.
Get your name on board. They're going to send a flash drive with this test flight, and it's going to be. It's just a fun thing, and they'll give you like miles and a boarding pass. Oh, here's mine. Here's my boarding pass. It's just a really fun thing, and I think it's great to get people involved, that kind of thing. They've opened up, it's tomorrow, they're opening up the 3rd round of the Nominate a Student with Perseverance. I really love this because, teachers will recognize their young people. Yeah, there it is, 6th through 8th grade students. This is in the U.S., public, private, homeschools. They've got 4 rounds total, and there are some pretty cool awards. There is another slide, too, that talks about, like, the sequence. Tomorrow they open, there it is. And some of the awards are really cool. Like you can talk to the rover team, and then you'll get a message from Perseverance and kind of a printed pack of materials. So I really like this one too. Again, citizen science thing. It's called Globe at Night. The first one between now and about a month is March the 23rd, goes through April the 1st. It's a 10-day project, and they assign sort of a constellation. They have for the southern hemisphere, it's Crux, and for the northern hemisphere, it's Leo. So what you do is you go out, you take pictures, and you compare to what you see on their site and report on like your location, that kind of thing. And so the next thing I want to talk about is this is really cool. And I have this wonderful Farmer's Almanac. And I'll just read a little bit of it because this is really exciting for me to think about things like this. They say, look for a triangle from the 24th to the 26th, with Mars on the right, Saturn to the left, and Venus at the top. 28th, the waning crescent moon dangles below the triangle's remnant, and it's a nice 4-way conjunction. Stuff like this, it's just beautiful. That's cool. Going to be early morning. Early birds will like this, and you're going to want to look in the east before sunrise. So a couple of significant things too. March the 25th is the last quarter moon. On the 27th, like we said, Mars and the moon are in conjunction. The 28th, Venus and the moon are in conjunction. And Saturn and the moon are in conjunction. On the 29th, Venus and Saturn come closer together. Again, before sunrise in the east. Venus is still pretty high and still pretty bright. We've got the new moon on April 1st. First quarter moon is April 9th. And the full moon for April is called a full pink moon. That's on April 16th. In fact, this is the day before Easter, which is the 17th. Don't forget about Easter. Then we get to the other Globe at Night project. This is going to be April 22nd through May the 1st. They still want you to look at Leo and Crux. It's really just very easy. You can even do it on your cell phone. You go out, bring up the program, take the picture, and it has it all right there. You just compare it. All right, so now we're to our meteor shower. This is the Lyrid meteor shower. And its dates are 16th to the 30th, so you can see the Lyrids kind of any time in that range. the kind of exciting point for most of us is the peak, and that's April 22nd. So we're talking about like April 22nd into 23rd, because they're saying the best time to go look for these are after midnight, and they do radiate from is it Lyra? Is Lyra? I think is Lyra, right?
Mm-hmm.
And that's part of
Lyra.
Lyra, okay. It's part of the summer triangle. So that's kind of exciting. It's like, oh,
That's nice to have something for night owls.
Yes. And there's a lot of things usually. Right now, it's early birds. And this source, well, okay, the peak rate per hour is 10 to 20, so not super exciting. And the moon may interfere a little bit as the night wears on. And this source is Thatcher, 1861L, I guess it is. And the moon is 22 days old. Last quarter moon is on the 23rd. So, some nights are better than others for meteor showers. This one's in between, I would say. So that's kind of the report on those.
Very cool. I'm going to go see if I can see that. So what was my day to see that, the square, the diamond? Mars, Saturn, the moon, and Venus?
Yeah, so they're saying look for a triangle from the 24th to 26th, and then on the 28th with the waning crescent moon, it'll be kind of joining that for a four-way conjunction. That's
cool. That's awesome.
Yeah. Wow.
Right on.
Yeah.
Okay, Moya.
Yes.
Ganymede. Finally, from love for Ganymede.
Finally. You know what? Ganymede is really cool. And I agree, it doesn't get as much attention as it should. It's the new Europa. But that will change. Yeah.
Ganymede is the new Europa. Heard it here.
Yes, I will get to that in a second. So the big story here is that in June of last year, the Juno spacecraft flew about 1,000 kilometers away from Jupiter's moon, Ganymede. And scientists are still combing through that data that it sent back, but it's already changed the view that scientists have of this Jovian moon, which is great, because it deserves it. So Ganymede, if you aren't familiar with the mythology, with the source of the name, is named after the beautiful young boy from Greek and Roman mythology who served as Jupiter or Zeus's cupbearer. And it's the biggest moon in the entire solar system. It's bigger than Mercury, maybe, I think. Do you know that?
Yes. Yeah.
Yes. Bigger than Mercury. This is not the first time that Ganymede has been imaged. It was imaged twice before. Once in 1979 by Voyager 1, and then again by Galileo in 1996. But those images, because they were back then, they were blurry. They had poor lighting. Were taken from awkward angles. So they didn't actually give us a view of what was happening on Ganymede's surface. These new images from Juno reveal features like several impact craters that are bigger than 60 miles across, and a bunch of smaller ones too. Overall, these Juno images increased the number of craters that we had found on Ganymede by 30%, which leads scientists to believe that Ganymede is more volcanically active than they previously thought.
Cryovolcanically active?
Yes, cryovolcanically active, because they're not hot lava monsters like the volcanoes we have on Earth. Instead, Ganymede has cryovolcanoes that spew frozen water and gas from inside the moon's, from under the moon's surface. But the craters aren't the only thing that this new Juno data sent back to us. It also revealed the exact sites of aurora happening on Ganymede. We knew about the aurora already. They were imaged with the Hubble Space Telescope several years ago, I think in like 2015. But we did get a more accurate view of where these aurora are actually happening. So Ganymede is the only moon in the solar system that we know has its own magnetic field. And when Ganymede's magnetic field interacts with Jupiter's, which is very strong, it forms aurora. And now a scientist can see the actual distribution of these lights and how they change going from the poles to the equator. Apparently they're more focused at the poles, which is pretty cool. What else? Its magnetic field is really interesting because because fluctuations in the field have led scientists to think that Ganymede is hiding a giant salty ocean under its surface.
Wow.
They think that ocean is 60 miles deep, and if so, then there would be more water under the surface of Ganymede than on the entire surface of the Earth. Great. Yeah, so it's like the new Europa. We think that this might be a good source for looking for life elsewhere in the solar system, but we need to know more. So Ganymede will be the target for the upcoming JWST mission that's supposed to launch next year. JWST is another one of those amazing astronomer acronyms that stands for Jupiter Icy Moon Explorer. And it will focus on Ganymede to learn what's going on underneath its surface.
Wow.
Yeah.
Very
Yeah.
cool.
Everyone's excited about Europa, but as you say, Ganymede also has a subsurface ocean, but it also has a magnetosphere. It's farther away from Jupiter, so it's not in the same amount of harsh radiation environment that Europa is. It has more mass, more gravity, so probably retained its heat a lot better than tiny, relatively small Europa. So it's a really exciting place to go. We don't know if there's any geysers coming out of Ganymede, but JWST will find out. And JWST is going to be doing flybys of Europa and Callisto, but it's going to settle into orbit around Ganymede and just really give that moon the examination that it really deserves. And
Do we know
Good.
the instrument complements that we have on board yet? Do we know what they're going to send?
Sort of
I
like what
don't.
instruments?
Yeah.
I don't think there's anything special like just this standard imaging, mass spectrometer,
Cool.
the maybe a laser altimeter. The thing that's interesting on the Europa Clipper mission, the one that's really interesting with that mission, is that they've got a ground penetrating radar on board. It's very power hungry, but it's going to allow it to look below the ice dozens of kilometers to try and really map out if there are sub-ice chambers and how water could be, if there could be pockets of water could be shifting around inside, almost like lava chambers on Earth. So
neat.
So, and I don't think JWST has the same suite of, it doesn't have that same instrument to be able to bring to Ganymede. I could be wrong, but this is what I'm sort of remembering off the top of my head.
I was just curious, see if anybody knew. Yeah, good.
Yeah,
cool.
Yeah.
Yeah,
Thanks.
I know it's supposed to launch next year and should get to Jupiter around 2029-ish.
Yeah.
Do you know why Ganymede has been ignored? Like, why did Europa and Enceladus get all of the buzz about having subsurface oceans when Ganymede was just right there?
Well, I think it's because we could see them. So with Enceladus, you've got the tiger stripes at the south pole of Enceladus, and it's very clearly throwing ice out into space. Yeah. And the evidence for the geysers on Europa is tantalizing. It's not as confirmed, but definitely these seem to exist as well. So geysers have not been detected directly at Ganymede in the way that they have with Europa. So I think that's it. Just that with Europa, it was very obvious that there was a subsurface ocean underneath. The way the ice looks, clearly it was being resurfaced, and I think it has been dawning on the planetary science since this discovery with Europa. Like, wait a minute, Callisto, Ganymede, Titan, Rhea, all of these, Pluto, Charon, Sedna, suddenly all of these worlds probably have subsurface oceans. They're everywhere. There are more of these places than there are, I've heard an estimate that there are 1,000 times as many sub-ice oceans in the universe as there are terrestrial planets like Earth. So the vast majority of habitable places in the universe are places like Europa and Enceladus and Ganymede.
Was that with moons specifically in mind, or
just
lumping moons and planets together?
Yeah, moons and planets. Moons, planets, Kuiper Belt objects, Oort cloud objects, planet nines, anything that is beyond the frost line that is of significant size and has a lot of water is going to have a subsurface ocean. And and that there is probably a lot of these worlds, because you can even, they think Mimas is the latest one that they think has found a subsurface ocean, and it's tiny compared to even Enceladus, which is tiny. And so it looks like these things can be really small and have a subsurface ocean, and they can be really big and have a subsurface ocean.
Yeah, because I was thinking if it's hot, if it's big, it's hot in the middle still maybe, and that would give, a liquid. I mean, you could make a liquid from that, not just
you need the tidal interactions. So you need to have that tidal flexing coming from some other object. So with Jupiter or Saturn, or if it is big enough, then it can just have leftover heat from formation, as well as the radioactive decay of material inside it. So,
that's what I was thinking.
Yeah. And
cool.
And even things, the thought is even like rogue planets that are just that have no star probably have subsurface oceans. The moons of brown dwarf or planets around brown dwarfs probably have subsurface oceans. So they're everywhere.
Yeah.
The problem is they're going to be really tricky to detect. But there's been some interesting science that just came out this week. They were talking about research is being done to sort of study the ice, the colors of the ice, to see how here on Earth different colors of ice reflect different kinds of life forms, different kinds of material, and even byproducts of life that are trapped inside of it. And based on that, they think they can then analyze the ice even from the surface and try and get a sense of what could have pooped in the ice or lived and died in the ice. So
do you mean analyzing the physical ice, or just the light from it and how
analyzing
things
the light
reflect
from
off of it?
Yeah, so analyzing it from afar. And so they're in the Arctic studying different ice formations and using that as a way to try as an analog to consider what it would be like to study Europa, Enceladus, Ganymede, all these places. So with Enceladus, Europa, you can have your spacecraft fly through the plume directly and taste it, and you might get a shot at detecting some kind of byproduct of life coming into the plume.
But one thing I know, that we're going to get surprised. We always do.
Yeah.
Every surprises out there.
That's exactly it.
Yes.
I love it.
Yeah. Awesome.
That's exciting.
Yeah.
Wait, before we move on, I have to point out what I think is an unintentional pun on Pamela's part, but it's just too good for me to pass up. It's here in the chat. Pamela typed out Ganymede, but spelled it Ganymead instead of Mede. But since Ganymede was a cupbearer, it's actually a perfect accidental spelling.
Kind of goes with the tasting part too.
Carrying mead. Perfect. Cool. Well, I've got a couple of quick stories I just wanted to throw in here because we are a little shorthanded tonight. So the one is we saw the rollout. I suspect Pamela doesn't have this queued up, but we saw the rollout of the Space Launch System last week. And this is, of course, the gigantic moon rocket that NASA and many contractors are building. And the first one is going to be called Artemis 1. And this is where it's going to be taking the Space Launch System with the Orion capsule. And it's going to be launching from Cape Canaveral, going on a trajectory around the moon, taking Orion around the moon and bringing it back. There'll be nobody on board, but a bunch of science experiments. So
and really our names. Don't forget our names.
And our names. Yeah, exactly. Which
we'll all be on board in spirit.
Yeah, we will be on board in electron form.
Right.
And so they rolled out Space Launch System to the pad, took all day to do it, and now it's out at the pad. And so now they're doing a bunch of tests. They're going to be filling up the propellant and then draining the propellant and doing a bunch of other tests just to make sure they can handle all of these various preparation for launch day. Then they're going to roll it back into the vehicle assembly building and do any other final tweaks and improvements, and then we'll probably see it roll back out probably May. So we may see a launch. We still don't know when we're going to see a launch. but early summer seems to be the number. I wouldn't be surprised if we see it launch sometime in June, July, but no one's actually given us any kind of announcement. And that's Artemis 1. That'll be no humans on board. And then the next missions that'll be coming up next year will start to build the Deep Space Gateway and also ideally return the astronauts back to the surface of the moon. We'll have the first woman setting foot on the surface of the moon, which is going to be great.
Yep.
Yeah, so there Pamela did put up some pictures. It's just it's a gigantic rocket. Have you guys been to the vehicle assembly building? Have you seen this building?
Is it Cape?
Yeah, Cape Canaveral.
No, I've been to one out here at Vandenberg when I worked at Boeing. I took a trip out.
Yeah, the Vandenberg one is not the scale of the vehicle assembly building, and I forget the exact stats on it, but it is so tall that it actually has a weather system that is inside the building, and I think it is like, and I'll have to remember this, but I think it's like the largest enclosed space in the world. Like it's some ridiculously large building, and yet when SLS rolled out of it, it just barely fit. It's crazy. If you look at the pictures, you'll see it, and it is just barely getting, in its launch gantry, coming out of there you go, yeah. And like it's just like that is, it is hard to explain. So the flag, the red lines on the flag, their width is the length of a school bus.
Wow.
So it is a ludicrously big building, and to stand next to it is just awe-inspiring. So it's kind of amazing. But yeah, so that's really exciting. Now the other thing, there you go. Master Toy Maker is saying it's the highest point in all of Florida, which is great. And if you actually ever get a chance to go out to
low.
Yeah, if you actually ever go to the Kennedy Space Center, you can take a tour and go out onto the Cape Canaveral, and you can go past the vehicle assembly building, and you can go, and they actually have a Saturn V laying on its side that you can go and check out, and it's a monster too. But they're roughly the same size, and so if you imagine what it was like to be back in the 1960s, 1970s, and going out to the Cape and watching the Apollo astronauts head off to the moon, you're going to get a taste of it, because the Space Launch System is the same class of rocket, which is really big. So it's pretty great. And then the other really interesting piece of news that came out this week was, we know that SpaceX has been awarded a contract to provide the lander for the Artemis missions. And so originally they had a bunch of contractors compete. Boeing, I forget the name of the company.
Yeah, they landed on 3.
Dynetics. Anyway, so they ended up going with Starship, so the SpaceX Starship. And this week, NASA released a document that explained in detail how they're going to be incorporating Starship into their mission. And so the plan is that a Starship will launch. There'll be the lunar lander, and it doesn't have any capability of coming back to Earth, no heat shield, etc. And then it's going to go into orbit around the Earth, and then they're going to launch another 4 spacecraft, which will provide propellant to the lander.
Wow.
And then the lander will then fly out and go into orbit around the moon. And then Space Launch System will launch with the Orion capsule and the crew on board. It'll launch the Orion to the moon. The Orion will dock up with Starship, and then Starship will go down to the surface of the moon. The astronauts will prance about on the moon the way they do, bring some rocks. They'll get back up into the Starship, get back into their Orion capsule, and then return back to Earth. And Starship will remain in orbit around the moon, ready to handle future visitors. And I'm not sure how many landings Starship has. Like, what's kind of amazing about Starship is that it's so big and it has so much fuel on board that it's just a whole other scale of what's possible. And so, like, you can see the picture right now, the astronauts are going to have to take this little elevator and go all the way down from the top of the Starship down to the bottom, and that whole bottom part is filled with fuel, and so it can make powered landings from the surface of the moon.
Is it going to like shuttle between the orbit and the moon?
Yeah. So it's going to go up to the moon. It's going to go up to the moon, and then it's going to be in orbit around the moon. It's going to land on the moon. Astronauts going to do their thing. It's going to fly back up into orbit, stay in orbit, and and I guess in theory they'll eventually be able to refuel Starship and keep going through this process. So
it's amazing.
How long is it supposed to last?
I don't know how many flights they have in them.
Depends on the fuel capacity.
Yeah, how much propellant. Yeah, like I'm not sure how many landings Starship will be able to do when it's fully refueled. That's a number that I don't know. But it is kind of a fascinating idea, and you can sort of see, like, if Starship actually works and if Starship can actually come back through the atmosphere and land in its launch gantry and be refilled and go back up to space. It's kind of ridiculous that Space Launch System is part of this mission, because we heard that these are going to be costing about $4.1 billion per launch for Starship. Well, sorry, for the Space Launch System, which is ludicrous amount of money. While Starship, that's less than Starship's entire design cost, and Starships will probably fly for a couple of $1 million per $5 million per launch to carry propellant to space. So it's sort of weird. Like, if Starship does act as planned, then it sort of negates the need for the Space Launch System, which is kind of crazy. And then the last thing I just wanted to talk about, and again, I'm not sure if Pamela has this ready, but which is the final image that we got from James Webb. And so now we got another sort of incremental improvement of JWST, where they finally have the telescope in focus, and to essentially what they described it as the best. They took the best focus, the best optics that the laws of physics will allow a telescope of this size to take, which is quite incredible. And so you got, again, this test star, but now it's one crisp star that's very overexposed. You can see all of the rays coming out of it, and that's a whole other rabbit hole that we've gone into to explain why it's got these rays coming out of the star. It's overexposed. It matches the hexagonal. It's essentially, it's diffraction coming from the hexagonal segments of the mirror itself. And so all of the various mirror segments, as they have along the edges of the mirrors, you get a little bit of light aberration that sort of comes together to form this. And also, because you get diffraction spikes that are coming from the part that are holding the secondary mirror. And you see this with Hubble Space Telescope. Really, if you have a reflecting telescope, you'll see diffraction spikes like this. And so you get these artifacts. They only happen when you heavily overexpose your image. When you point at a star and you point it for way too long and you make it unusable for science, but you're testing focus. We all do this whenever we're using a telescope. Get the focus first, then. But the part that's incredible with this image is that in the background you can see all these faint smudges, and what they are galaxies.
I was gonna say, are they galaxies?
Yeah.
Oh my god.
So JWST deep fielded just by the process of them doing a calibration image. And it's if you've done much astrophotography, like when you overexpose it's a very bright star for JWST, and so it's exposed but not incredibly overexposed, and so it's not a very long exposure. My guess is a couple of minutes at the most. I mean, who knows? And yet they get all of these faint background galaxies, the kinds of stuff that Hubble would turn up in its deep field. and so it just is deep fielding by just because it can.
Wow.
No matter where they look, it can deep field.
So,
And this is one of the. Go ahead. Pam.
Finish. I
I was going to say that one of the capabilities of JWST is that it will be able to deep field anything that Hubble could do with dozens, hundreds of hours of work. It will be able to do rapidly.
Yeah.
There you go. So Zappan is saying, 30-ish minute exposure.
Oh, 30 minutes. Wow.
That's a 30-minute exposure on a very faint, on a I think it's an 11th magnitude star. Like, you couldn't see the star with your own eyes. You would need a backyard telescope to even see this star. And the kinds of galaxies that some of the most interesting galaxies that Hubble took were these ones that were redshifted right to the very edge of what Hubble was capable of seeing. And the only way it could see it is through gravitational lensing, using some foreground galaxy to act as a natural telescope, a booster lens for Hubble. But in the case of James Webb now, it can see all the stuff just directly.
Wow.
It can look in any direction, and it can deep field. And we don't even know what the deep field of JWST is going to be, because it's seeing in a wavelength that Hubble just can't see.
Right.
So we're about to see things that astronomers have been dreaming about for 20 years.
So worth the wait?
Worth the wait. And we're not done yet. There's still, I think they finished 5 of the focusing instrument preparation stages. They've got a couple more to go, and then we will have a fully operational space telescope.
Yeah, I remember talking about that, and
So
they were
exciting.
like, they're talking about how long it took and how all the things had to be right because it's so far away, and it's like, I think it's worth the wait.
Yeah. Where are all the haters now? Oh, I hear crickets. That's what I hear. Just crickets.
Yeah, it's good. It's going to be, and we're just getting started. That's a really exciting part to me.
Yeah. All right. Well, we've reached the end of our show, and what do you know? We were able to figure out a way to make it last to go the distance, to make it last the full hour. So I want to give my co-hosts a chance to shamelessly self-promote what they're working on. Pam, what are you working on, and where can people find out more?
So we have a live show every Friday night at 9 p.m. Pacific time, and we're available on the Everyday Spacer Facebook page, Everyday Spacer YouTube channel. In fact, on Friday, we're going to cover different ways of launching things off the Earth. There are 10. I had no idea. That's Friday, March the 25th. And I'm thinking about something for April 1st, which is the following Friday, maybe astronomy hacks. Unless, of course, Jeff is doing Friday's show, he may need a part 2. So we'll see what happens. And we do invite people to share our lives as a guest. They can come twice a year for open mic night. And, we take listener questions every single episode, kind of randomly whenever they show up. So
awesome. Dr. McTeer.
Hi, you can find me on Twitter. I'm GoAstroMo, and you can pre-order my book now. It's called The Milky Way, an autobiography of the galaxy. It talks about the history and formation of our galaxy, but from the Milky Way's point of view. It's very sassy, pretty irreverent. I've heard that people find it funny, which is good because that's what I wanted. You can pre-order that. It's the pinned tweet on my account, but you can also just Google Moya McTeer, The Milky Way from Grand Central Publishing. Please pre-order because it helps the publisher know that people actually are interested in stuff.
Awesome. That's great.
So, of course, I'm Universe Today on all the things. And I didn't realize this, but Nancy Atkinson brought this to my attention today, that it is Universe Today's 23rd birthday.
Wow.
So I have been doing this job. The first time I did this was March 23rd, 1999 was when I started up Universe Today and wrote my first article. And I have been doing this job for 23 years since then.
That's amazing.
For at least 23 more. So
awesome.
Happy birthday, Universe Today.
Yay!
2 more to get to 25.
Very cool.
And I'm just trying to think. Yeah, you were born by then, right, Moya?
Yes. Okay. I am older than Universe Today.
Universe Today. Okay, good. Good. All right. but I'm sure some of the people watching aren't, and that just makes me feel old. All right. Well, thank you everyone for joining us this week. Thanks to my hosts for jumping in and bringing the news. Thank you to all of the moderators, people watching us both on YouTube and on Twitch. Thanks to Nancy Graziano for keeping us organized, and thanks for Pamela for engineering the show behind the scenes. All right, and we will see all of you next week. Thanks, everyone.